Question 6. Evaluate the definite integral from -1 to 4. So if I look at this guy over here, I'm just going to rewrite it. Okay, if I look at this guy over here, you're going to be like, oh, big fraction quotient rule. But remember, quotient rule is not applicable to integration, only differentiation. So I need to think, how am I going to deal with this? And the general rule of thumb is when you have a top-heavy fraction, and like where you have 3 terms here and 1 term here, then what you have to do is you have to split this up as 3 individual terms, and then you integrate each individual term. So if I split this up, I'm going to rewrite this as 2 divided by the denominator minus x cubed divided by the denominator minus 3x to the 5 divided by the denominator dx. Okay, the reason why this works is I'm essentially just using the very basic fractions principle, which says that if I have 1/3 plus 5/3, where they have the same denominator, you can combine the top, so that's 6, and then the denominator stays the same. I'm actually doing this, but I'm doing it from this way and then splitting it up like that. Okay, so now I just need to simplify it and then integrate them. So it's going to be a lot of work to get it into the form where it is integratable, but once it is, it's boom, same thing, easy as. So first of all, I have 2/3 x squared. Anytime you see x on the denominator, bring that guy up. So we end up with 2/3 x to the power of -2. And then for the next portion, we're going to cancel some x's out. So are we going to cancel out 2 x's? We're left with 1 x at the top. So that's -1/3 x. And then I'm going to cancel out 2 here. We're left with 3. Oh, and these 3's cancel. So we're just left with -x cubed. Okay, beautiful. And now that it's in this integratable form, we can go ahead and integrate it. So we get 2/3 times, when I increase this x by 1, we get x to the power of -1 divided by -1 like this. And then next, if I increase this x by 1, we get x squared divided by 2. And then this increases to 4 divided by 4. And then now I just need to clean this up a little bit. If I have 2/3 times -1 down there, we get -2/3, and I'm going to write x on the denominator, so with a positive power instead. And then now we're going to have -1/6 x squared. So how about we write it as a singular fraction, -x squared on 6, and then this is just -x to the 4 on 4 plus c. Oh no, it has limits, so I actually can't do that. The limits are from 4 to -1, so we're going to do the little square bracket business and sub it in. By the way, my little trick for doing this is do not put the entire thing in the calculator. You're going to make it so that it's very prone to making a mistake. So what I do to be efficient as well is I put in the first portion in the calculator. So if I put that in, we get -401/6, and then, so we have minus, and then I'm going to put this portion, just what's in the bracket in the calculator, but you don't clear it and do it again. You backspace and you replace all of the 4's, because the upper limit is 4, replace all the 4's in your calculator with -1. And just make sure that it's in brackets as well, because that negative is a little tricky. Okay, so we get +1/4. So now if I put this in the calculator, we are going to get -805/12. Now, I know what you're thinking, because I can read minds, but I know you're thinking, why is it negative? Now, you can absolutely have negative integrals. What it essentially just means is that if you were to sketch your curve from 4 to -1, a larger proportion of it should be underneath the x-axis. So that's it. That's all it means. If you were to find area, then what you do is you just make sure that whatever portion is underneath the x-axis, you just chuck absolute values on it to force it to be positive. But negative integrals are allowed.